Good afternoon, ladies and gentlemen. This is Mr. Holmes getting ready to talk to you guys about factoring binomials again. However, in this case here, we're talking about perfect cubes. Now, with binomials that are perfect cubes, in a binomial that's a perfect cube, both terms must be just that, a perfect cube. If you've forgotten what a perfect cube is a number or a variable or a term that you get when you multiply that term times itself 3 times. For instance, x times x gives us x cubed. Therefore, x cubed is considered a perfect square. A perfect cube. 8 would be considered a perfect cube because 2 times 2 times 2 gives us 8. 27 also would be considered a perfect cube because 3 times 3 times 3. Now, I've given you 3 different examples of perfect cube binomials. All right, so here, let me number these here as number 1, number 2, and number 3. You can see all 3 of these are any variation of these. I just want you to understand the concept of a perfect cube and breaking it down, factoring it. All right, so when you get ready to factor perfect cubes, there's a pattern that goes with perfect cubes, and I'll write this pattern at the bottom of right in the middle of the page so you guys can see. The pattern is to take the very first term here, and since I'm dealing with the difference, it'll be minus. If I was dealing with the plus, it'll be positive. But you're going to take the very first term that was cubed to give you the first term of your binomial, and you're going to subtract that with the second term that was cubed to give you your second binomial, times that first term squared plus, and that's right, plus the first term times the second term plus the second term squared. Now, I know what some of you guys may be thinking, well, what do he mean? 64 squared? Well, that's kind of a big number. Well, 64 is not necessarily your B value. Even though 64 is the second term in your binomial, you're looking for what number was cubed to give us 64. What was cubed to give us x cubed? All right, so I'm going to color code this to make this as obvious as possible. In this case here, x cubed, well, that's kind of obvious. All right, we know that it took x to be cubed. And in this case here, it took 4 to be cubed in order for us to get our x cubed minus 64. So in this case here, my value of a would be the term that it took to get x cubed. In this case, this term is x. The term that it took to cube to give us 64 was 4. 4 times 4 is 16, and 16 times 4 gives us 64. So my second term in this case would represent b, which is 4. From there, we'll follow this pattern. All right, so let's go ahead and get started. My first term here is going to be my a minus my b, so my first term is going to be x minus, and I'm saying minus because my original binomial had a minus in it, minus 4. And then it tells me to open up a set of parentheses, take my first term and square it. My first term is x, so I'm going to take x and I'm going to square it. Then it tells me to multiply my first term times my second term. In this case, x times 4, which will give me 4x. Lastly, I'm going to add, and it tells me to take my last term and square it. In this case, 4 squared, and it gives me 16. Believe it or not, guys, that's all there is to it. In this case, this binomial is considered factored at this point. All right. Let's look at question number 2. In question number 2 here, I have 27y cubed minus 243. Now, even though I skipped this question in question number 1, you should always ask yourself before you get started on factoring any polynomial is, does there lie a GCF that can be factored out? In number 1, it was kind of obvious, there were none. But in number 2, notice you have 2 numbers. If at all possible, look to see if you can divide any one of these here by obvious factors of 27 besides 1. like 3, like 9, like 27. In this case, you'll find that there are none. That being the case, we're going to go ahead and look to see if this is a perfect cube. We must ask ourselves, does there lie factors of 27 that you must multiply 3 times and it will give you 27? Like I discussed earlier, it actually does. All right? So we're going to have this term here will be cubed minus this term here will be cubed. This is how you get 27y cubed and 343. The term that was cubed to give us 27y cubed. Well, we know if we cube 3 times 3 times 3, it will give us 27. So the cube root of 27 is 3. And obviously, y was cubed in order to give us y cubed. So 3y cubed gave us 27y cubed. Therefore, 3y will represent our A in our pattern. The second term we have to ask ourselves is, what was cubed to give us 343? Well, that number is 7. 7 times 7 is 49. 49 times 7 gave us 343. That being the case, 343 is considered a perfect cube. And 7 will represent the letter B as our second term in our binomial that was cubed. So here we have our pattern. All we're going to do is just substitute in our A and our B into our pattern. In this case here, we say A minus B. So in this case, we will have our 3y minus 7, close parentheses. Then we ought to open up another set of parentheses. Take our first term and square it. 3y squared. In other words, 3y times 3y, and this will give us our 9y squared. We're going to have a plus. Our first term times our second term. 3y times 7. This would give us our 21y. Lastly, we have our plus, and we are to take our second term and square it. In this case, 7 squared, which will yield 49. What we've just done, we've just factored this binomial, this perfect binomial cube. All right, this perfect cubed binomial, with 27y cubed minus 343. We found the two factors that was perfect cubes to give us, that were cubed, to give us our 27y cubed minus 343. We used those with our pattern to factor out, to this binomial. Lastly, I have number 3. Number 3. But again, the first thing we should always ask ourselves is what does there lie a common factor that both these terms share? In this case, notice that 16 and 2 are both divisible by 2. Therefore, we have found a GCF. My GCF would be 2 and G. Since both terms have a G, we can take out G. We cannot take out more than one G because my second term only has one G. So we're going to start off with my GCF on the outside of my parentheses. So in this case, my GCF is 2G. To get the remaining portion of my binomial here, I must take and divide each one of these terms by 2G. When I do this here, 16 divided by 2 will yield 8. G to the 4th divided by G. Remember, when you do not see an exponent, that exponent is 1. And because we're dividing variables, you must subtract the exponents. In this case, 4 minus 1. This will yield G cubed minus. Some students have a tendency to subtract here and get 0. In this case, they're making a mistake. You should be dividing. 2 divides 2 and G divides G all one time. 2G divides 2G. We was taught from elementary school that anything divides itself once. That's where we get this 1 from. From here, we're going to notice in this binomial, it looks like we're done. However, the number 8 is a perfect cube. If you didn't know that, look at the exponent, and as soon as you see the number 3, let's start asking ourselves right now, does that lie a number times itself 3 times to give us our 2 numbers here? In this case here, 8 and 1. Now 2 times 2 times 2 gives us 8. Therefore 8 is a perfect cube. G clearly is a perfect cube, and 1 is a perfect anything to any exponent. Okay, so because that being the case, my GCF will remain in my process as well as part of my final answer. However, I have to ask myself, what factors were here that was cubed to give me my binomial 8g cubed minus 1? So in here, I know 2g was cubed to give me 8g cubed. Here I know the number 1 is clearly cubed to give me the number 1. And now I have my minus here. So now I have the value of A and I have the value of B. My A is 2g, my B is 1. And I'm going to use the difference of cubes to simplify this. On the outside of my parentheses will lie my 2g. And I'm going to use my pattern to help me out with the rest. Since 2g is my first term, I'm going to go back up here in my pattern. It's going to be A minus B. In this case, 2g minus 1. Close parentheses. I'm going to open up another set of parentheses, and it says take the first term and square it. My first term is 2g. So 2g times 2g will give me 4g squared. Plus, it now tells me to take the first term and multiply it times the second term. 2g times 1, which will yield 2g. Plus my second term squared. My second term in this case here for b is 1. So I'm going to take 1 and I am going to square it, which in this case is still be the number 1. Notice in my binomial, it is not a perfect anything. There's nothing else to factor out of here. Therefore, we are done with this binomial, and there's nothing that we can factor from this trinomial. Therefore, we are done. So guys, there you have it. My binomial, my perfect cubed binomial has just been factored. In its final answer, you will have 2g times 2g minus 1 times 4g squared plus 2g plus 1. As always, this has been Mr. Holmes. I hope you guys enjoyed this video, and if you know Mr. Holmes, you know what I say. I hope you enjoyed this video. Now have a blessed day.